We're the ready-to-use therapeutic foods group from Ghana. I'm Ricky Aini.
Caitlin Leahy.
Zane Graper.
I'm Cholu Yu.
Okay, so ready-to-use therapeutic foods was kind of our goal of the project, and the goal of our project was to design a process to be in Ghana. So we're trying to develop this facility to cure severe acute malnutrition by creating a product that is both high in fat and high in protein to give to these children in Ghana.
Severe acute malnutrition is what we're trying to cure, which is basically just a very severe form of hunger. So from here, the number of children under the age of 5 with severe acute malnutrition in Ghana is about 57,000. So we based our product, we're trying to market it towards that number of kids. So using our production rate, after about a year, more than half of the kids with SAM will have been cured from it. There's a very low turnover rate, so the chances of them getting SAM after being cured are very low. And of course that number will grow, but our goal is to diminish it over time. So the dosage is about half a pound a day for 6 weeks, and after that you're cured. So that's how we got our number of how many children we cured. And if you'll see, our price might seem a little high, but we are not selling directly to the consumer. We're actually selling to the Children's Investment Fund Foundation, which is like UNICEF. So they're a non-profit, and they would be distributing this product. And this is just our equipment cost breakdown, which will go into processing later, so you'll understand what all of this means. And this is our payback period and return on investment.
So some of the experimentation that we did experimentation with milling the grains that are the ingredients going into our product. We had to find a uniform particle size before we could mix it in with the ingredients and extrude it. But a lot of the experimentation we did was with the extruder itself. And this is the extruder we used. It's actually the second extruder. The first one we used wasn't powerful enough. And extrusion is the same process that they make Cheetos. And when we sent our grains through the extruder, it actually it was a lot like a Cheeto, except more dense and a long string. And we also did experimentation on pasteurizing our final product. At the beginning of this project, we had the mindset that we were going to make our own formula, but it turns out Washington University actually had already done research on this and sent us a couple formulas. The formulas are high in protein and fat. They're specifically designed to help the malnourished state.
So as Sam mentioned, that we got all these formulas from Washington University in St. Louis. So we got this from the Department of Food Science. So what we're gonna do as an engineer, we're gonna design the process flow for this project. What we designed, it's like we have all these ingredients, and then we're trying to do all the experiments on the equipment that we're gonna use for this project only to find the optimal conditions for each cook, for each grain. So we have it, first we have these raw materials, and we're gonna mill it. Specifically for these formulas, it's peas and maize and oats and sorghums. These gonna be milled first, and then we put them in a mixer to mix them with water. So we got different moisture content to have them extruded. So after extruding, you're gonna get those kind of like a really dense Cheeto thing, and then we put these dense Cheeto extruded into a dryer to dry it, and then lower the moisture content to get a more dry, around 5% moisture content, and then we're gonna mill it again to get the powder of that extruded. Then we're gonna dry roasting the peanuts and pumpkin seeds, and then we're gonna mill those roasted seeds to have those peanuts and seeds powder. Then we're gonna mix these two powders and then all the other ingredients as well. So like oil, and then also mineral powders and then sugars, all the other stuff, putting into this mixer. And then we're gonna back grinding it again for the purpose of getting no larger particle size, because we are designing this process for children food, so we want to making sure there's no large particle size for those kids. Then we're gonna pasteurize it using a steam kettle to get rid of the microbial in there, to making sure the safety of this kid's food. And then we're gonna packaging it and then deliver it for the moms to feed the children. So if you wanna look at this, it's something that looks like peanut butter. It's our final product, and this is how we're gonna packaging it right now, but we are thinking about other solutions as well.
So we talked a lot about kind of what we do behind engineering, but also part of the ag and bio process is we kind of look at the societal and global impact of our process. And so kind of what we want to do is empower mothers to provide them the resources to provide their children with nutritional needs that they need to kind of create them into healthy adults. And that's kind of what our project does in a nutshell. Is we're trying to, you know, do all this engineering but also have some impact on Ghana.
So what was the biggest challenge you had in completing your project?
Okay, so we talked a lot about, we got the recipes from this Washington University, St. Louis, and we were told to use this extruder over here. We were trying to branch, you know, the food science that we learned with the engineering, because sometimes things work in theory, but when you go and try to actually do it, it doesn't work. So, you know, we were trying to find the optimal conditions to the different food products, just because, you know, there's a wide range of settings that you could run with it. So just finding the right one, and the right one to make the products that we need.